Hey guys, welcome back to my CCNA 200-301 course. Patrice is here, and in this video we are going to talk about first hop redundancy protocols, or FHRPs. Are you ready? Let's get started. Nowadays, businesses heavily rely on their IT infrastructure to operate, and each outage may cost millions of dollars for big enterprises. So it makes sense to invest some money and keep that IT infrastructure resilient. And redundancy is one of the key pillars of that resiliency. So it depends how much money do you have, or how much money your enterprise or corporate can invest in redundancy. You can provide redundancy in different levels or different systems and services. One of the redundancies that we can provide in networking is called first hop redundancy. In routing terminology, hop means router. So first hop means first router, which is normally the edge router of our offices. So we have an edge router that sits at the edge of the network and connect that office to the rest of the network. So we can provide redundancy for that router. And so if one router fails, the other router can take the responsibility and provide network connectivity for our office or building whatsoever. To provide first hop redundancy, obviously you need redundant routers and also a protocol that can handle this redundancy, which is the topic of this video. Basically, Cisco devices support three different first hop redundancy protocols, which are HSRP, VRRP, and GLBP. In the upcoming slides, first I walk you through some key facts about each of these protocols, and then I'll do some sketches and explain each of them separately. Let's start with HSRP. HSRP stands for Hot Standby Router Protocol, and this is a Cisco proprietary protocol. This protocol uses UDP port 1985 for handling HSRP traffic between the HSRP routers, and it operates in active standby mode, which means that at each certain point of time, only one router will be active and provide connectivity for you. And if that active router fails, then the standby router will take the responsibility and becomes active. VRRP, which stands for Virtual Router Redundancy Protocol, is pretty much the standard version of HSRP. And it's been introduced in RFC 5798. It uses IP protocol 112, and like HSRP, it works in active passive mode, which in VRRP terminology, it is called master and backup routers, or master and backup mode. And last but not least, GLBP, which stands for Gateway Load Balancing Protocol. And like HSRP, this is a Cisco proprietary protocol and uses UDP port 3222. And it operates in active mode, which is the key difference between GLBP and VRRP and HSRP, which actually makes it provide redundancy as well as load balancing. So at each certain point of time, if you have two routers, for example, both of those routers will be active and they can provide connectivity to your network. So you can load balance your traffic over the two routers. For HSRP and VRRP, we can do a trick and provide load balancing as well. I'll show you in a moment. Okay, it's time for a bit of a sketch. We start with HSRP. Let's assume that this is our office that sits on 10.0.0.0/24 subnet. And the gateway for this subnet is 254. This 254 is supposed to be served by these two routers, but this is not an IP address that we set on these interfaces. But what we do is we set a same subnet IP address on these two interfaces. So for example, for this router, we set 252 2, and for this router we set 253. I mean 10.0.0, 252, 10.0.0, 253. And this address will be set as the HSRP group virtual IP address. So you define one HSRP group per subnet, and then within that subnet you define your virtual IP addresses. So both of these two routers know, based on the HSRP configuration, what is the virtual IP for that HSRP group. But if you remember from the previous videos, when the computers or devices want to access an IP address, the first thing they do is sending an ARP request to figure out what is the MAC address that is correlate to this IP address. And ARP is a broadcast message. So both of these routers will receive that ARP request for 254. And the only device actually that will respond to that request or that ARP request is the active router. Let's assume that this one is the active router. So a standby router will receive that IP ARP request, and also it knows it should have the 254, but it doesn't respond to those ARP requests. And this is the active router's responsibility to respond to them and say, hey guys, I am the one that's supposed to serve this 254. And then the switch will actually understand which interface it is connected to and will send the traffic destined to 254 on this specific switch port. That MAC address has a specific structure. For HSRP, there are two versions. So we have two versions of HSRP, version 1 and version 2. For HSRP version 1, this address, this MAC address or virtual MAC address format is 000, 0C07, and then ACXX. For version 2, it is 000, 0C9F, and then FXXX. You can see that the number of X's are different in these two versions because these X numbers supposed to represent the HSRP group number. So with these two X's here, there would be 8 bits to present HSRP group numbers. So with HSRP version 1, we can only have 255 groups. But this one has 12 bits for that representation. So it can have 4095. Let me write it again. It would be 4095 HSRP groups that you can define with HSRP group 2. Version 2. And for HSRP version 1, these messages, the HSRP messages between the routers will go to 224.0.0.2, and for HSRP version 2, it is 102. So when these routers want to talk to each other with HSRP messages to check each other and make sure the other side is fine, etc., they will send those messages on these two multicast addresses for HSRP version 1 and HSRP version 2 respectively. And HSRP hello messages, which is the hello message between the routers so they can make sure the other router is still alive, will be sent every 3 seconds. So these routers check up on each other every 3 seconds. And if, which is called hello timer, and if within 10 seconds, they are the default numbers. If within 10 seconds, the other router do not respond to HSRP hello messages, the router will assume that the other router is dead. And if that router is the standby router, has to make an action because this guy is dead and now it's time for me to make action and provide redundancy. And the first thing this router does is sending an gratuitous ARP or GRP, which means that no one asks for that ARP for 254, but this one voluntarily send this ARP response. So the switch understands that from now on, this is not the interface that should send the frames destined to this MAC address, for example, 01, and this is the new interface. So our traffic destined to that 254 address will be redirected to this interface from that moment on. The other question is, okay, if this device is dead and this one now becomes active, what would happen if this router comes back? Will it take its active role back again or not? By default, for HSRP, not. This feature is called preemption. So if the active comes back, preemption is not enabled by default. So this will remain active and this will become standby. So you have two options. First, switch reboot this router or switch the active standby, or enable preemption, which is not enabled by default in HSRP. If you enable preemption, then when this router comes back, it will take the active role back from the current active role and becomes the active router. Another question is, who determines which router gonna be active router and which router gonna be the standby router? It is the priority that determines which router gonna be the active router and which router gonna be the standby router. By default, for HSRP, this priority value is 100. So both of these routers will be having the priority 100. So which one will become the active? The one that has the bigger IP address. So if this one is 252 and this one is 253, this one will become active if you don't define the priority of each router within the HSRP group configuration. The other thing is you can have more than 2 routers to provide redundancy for HSRP. But the third router will not be active or standby. It will be listening. So this will do nothing until one of these other routers fail. So if each of these routers fail, then this will come into the picture, and that election for if you haven't determined the priority, which would recommend to do that. For example, if this is supposed to be active router, we set the priority to 200. And for this one, we set it to 150. And for this one, we set the priority to 120. So if this one fails, for example, if this router or the active router fails and this one becomes the active router, then this will become to picture and will take the standby role in the picture. And again, if this router comes back, depends on the preemption configuration. It may take its role back if you configured preemption, or you may need to manually intervene. Now let's talk about VRRP. As I mentioned before, VRRP is pretty much similar to HSRP. So whatever I talked about HSRP mechanism, it works for VRRP. That virtual IP address, that virtual MAC address, how it responds to ARP requests, etc. Everything is the same. It's just about VRRP is a standard version, but HSRP is a Cisco proprietary. Now let's talk about the differences. The differences is with a virtual MAC structure. So for VRRP, virtual MAC address structure is quadruple 0, 5E, 0001XX. And VRRP, like HSRP, has 2 versions, version 2 and version 3. Version 2 only supports IP version 4, but version 3 supports IP version 4 and IP version 6. But the MAC address structure is the same for these 2 versions. And also based on this, you only can have 255 groups, no matter version 2 or version 3. The roles for VRRP, instead of active and standby, they're going to be master and backup. And if you have more than one router, the other one also will be called backup. So this one can be called backup 1 and this one can be called backup 2, for example. Hello timers for VRRP is 1 second in comparison to 3 seconds of HSRP. And the hold time is 3 seconds for VRRP. So VRRP routers will react faster than HSRP routers in failure situations. Priority, same, 100 by default. And if you want to select your router, you have to select the priority. Otherwise, the bigger IP address will be selected. The other difference is preemption. Preemption in VRRP is enabled by default. So in contrast to HSRP, which is not, and if you want to have that feature, you have to enable it. For VRRP, it is enabled by default. And the final thing is VRRP's multicast address. VRRP routers will send their VRRP messages to 224.0.0.18, no matter version 2 or version 3. Same for both versions. As I mentioned before, HSRP and VRRP do not support load balancing natively because at each certain point of time, only one router will be active and the other one will be standby. And so all traffic will be redirected to the outside world through the active router. In compared to GLBP, which has a smart level of load balancing, with HSRP and VRRP, we can do a trick to create some sort of load balancing, but it's not equal load balancing, depends on the traffics you have. This can happen by having more than one subnet. If you have only one subnet, this will not work. But if you have more than one subnet, this will do the trick and can provide some sort of load balancing for you. For example, if we assume that we have two sets of users with two subnets, 10.0.0.24 and 10.0.10/24. To make that trick, by setting the right priorities, for this subnet, we make this router the active router and this one the standby router. And for the other subnet, we make this one active and we make the other one standby. So with this setup, we will have our redundancy. If any of these routers fail, that situation will be handled by HSRP or VRRP. And also we can have load balancing as well. It won't be equal because the amount of traffic from this subnet might not be equal to this one. But anyway, we can use both of our routers at least. And because we may have actually invested a lot of money in the other router, and we might say that, okay, we spent like hundreds of thousands of dollars on this router, why can't we use it? At least we can engage this router and we can use it, although we might not be able to have the equal load balancing situation. GLBP is a whole different story. In GLBP, one of our routers will become AVG, or Active Virtual Gateway. And this AVG will be elected based on the similar parameter, which is priority. And that priority is again 100 by default. And if you don't set the right priority on the desired router GLBP group, then the IP address will be the tiebreaker. Alongside with AVG, routers will take another role, and that is AVF, Active Virtual Forwarder. And each AVF will have a different MAC address, different virtual MAC address. So in this case, we have AVF here and we have AVF here as well. This virtual MAC address in GLBP has this format: 0007 B400 XXYY. X as again are related to your GLBP group number. And again, since it's 8 bits, you can only have 255 GLBP groups. And the Ys are our virtual MAC addresses. Okay, so for example, for the top router, this is going to be like 01 in binary, and the second one will be 02 in binary. So I call this one 01 and call this one 02 based on the last digits of their MAC address. AVG is responsible for responding to ARP requests. So if this user sends an ARP request, AVG will not only respond with its own MAC address, with its own virtual MAC address, but also based on the load balancing algorithm, it will respond with the other router's virtual MAC address as well. So, for example, if this user asks for the ARP for the gateway address, which is, for example, 254, then AVG for this user will respond with its own virtual MAC address. So this user will be using this switch interface to send the traffic out to the gateway. But if another user asks for the same IP address ARP request, this time AVG will respond with the other router's MAC address. The response comes from AVG, but the destination MAC address is actually 02. So this user will be using this interface of the switch to send the traffic destined to the same gateway IP address. And this is how GLBP load balance the traffic per host. There are different load balancing methods that you can configure on GLBP. The first one is round robin. And round robin is actually, in all of the load balancing algorithms, means that distributes traffic equally amongst the service providers. So in this case, distribute the traffic equally amongst AVFs. The other one is weighted. Weighted means assign traffic based on the configure weights. So for example, if you have two routers with two different performances, you can configure the one that has better performance and more CPU power, etc. more weight, so that one handles more traffic in compared to the other one, which is like have less performance in compared to the other one. So you can load balance the traffic based on their performance capabilities. And the last one is host dependent. Host dependent means each client gets a consistent gateway based on its own MAC address. So every time this user asks for the gateway, it will be redirected to this one, and if this user asks, it will be redirected to this one. So it's going to be kind of stick to a specific gateway per user. The roles we talked about play a crucial role in failover scenarios as well. So in the first election, when the AVG determines, for example, let's assume that this is the AVG. Now this is the AVG's role to determine the AVF roles, and this will be happening dynamically. So AVG, for example, based on your configuration, will assign AVF01 role. 01 means the MAC address of 01 to itself, and AVF02 to the other one. Meanwhile, this router will become actually the backup AVG and also backup AVF01 as well. And also this router will become backup AVF02. And all of these role assignments are happening by AVG. What does it mean? It means that if this router fails, it is time for this router to take the responsibility of AVG first and becomes the AVG. And so if anyone asks for ARP request and sends ARP request, this router will respond to the ARP requests and also will send a gratuitous ARP and says, I am AVF01 as well. So from that moment on, switch will understand that this port will not be able to reach out to that MAC address anymore, and this is the new port for this MAC address. And vice versa. If this one fails, AVG will remain because AVG was this router, but the AVF role of this router will be transferred to this router, and this router will send a gratuitous ARP and say, hey, I'm here and I'm 02. So if this user used to send the traffic to this router without any experience, without any changes on the user side, it will be sending the traffic to the other router. And this is how GLBP load balance based on the host and can handle the failover scenarios. GLBP, like HSRP, hello timer is 3 seconds and the hold time is 10 seconds. And also the destination multicast address is 224.0.0.102 like HSRP version 2. And also preemption is not enabled by default on the GLBP. So if you want to have preemption, you need to enable it manually. Alright guys, this was our today's video. The CCNA topic we covered in this video was 3.5, describe the purpose, functions, and concepts of first hop redundancy protocols. And in the upcoming video, we'll be talking about management options. I wish you enjoyed today's video and see you in the next ones.